Hi there, I'm Josh Nightingale and I'm a PhD student at the University of Aveiro in Portugal. And today I'm going to talk about some work on juvenile social environment and its role in range change in Icelandic Black-tailed Godwits. So as we all know and as we've seen, species are often changing what they do. So the environment is changing very quickly and populations can often change in response. One that we all know about is global warming. In particular, it's very pronounced at high latitudes where a lot of waders breed. And species can change in space, for example, their distribution. One very common pattern across many taxa, including all sorts of birds, is a shift to higher latitudes. Species can also change in time. For example, a lot of migratory birds are arriving earlier. This is also true of waders that breed in Iceland, including the black-tailed godwit, which I'm going to talk about today. And social information can also play a role in these population changes. So for example, in Iceland, the oyster catcher can have two different strategies for winter. It can either migrate or be a resident. And the proportion of residents has been increasing. And what Veronica Mendes has shown is that the behavior of juveniles depends very strongly on the behavior of their father. So a juvenile with a migratory father will also tend to migrate, and a juvenile with a resident father will also tend to be a resident. So my question for today is, how does timing affect the social environment of juveniles and therefore affect their settlement? I'm going to look at this question with the help of my good friend, the Icelandic Black-tailed Godwit, which is a really useful population to study because for nearly 30 years now, large numbers of individuals have been marked and tracked all across the breeding and wintering range. So as the name suggests, this is a species that breeds in Iceland, and it can winter anywhere on the west coast of Europe, from the UK and Ireland in the north, down to Iberia in the south. And this is a species that is changing in space, so its breeding range has expanded a lot. At the beginning of the last century, it only bred in the southwest corner of Iceland, and has since expanded across the last century to colonize areas all around the coast. Similarly, the wintering range has been expanding northwards. From this collection of core sites that were used during the 1960s and 70s, it's been colonizing the north and east coast of the UK, and that's a trend that continues to this day. As well as changing in space, this is a species that's been changing in time. As well as the migratory dates that I mentioned earlier, the birds also are laying eggs and hatching earlier, which is a trend that Jose has linked to warming temperatures. So in a hotter year, they lay earlier, and this is a trend that we're seeing continue as well. So black-tailed Godwits in Iceland are simultaneously undergoing a range expansion and phenological changes in terms of an advancing breeding season. So for part one of this talk, I'm going to ask how timing of the breeding season affects the social environment of juveniles. And to answer this question, I went to Iceland and I did a field study. So I went to find post-breeding flocks where after nesting, adults and juveniles will form large flocks of tens to hundreds of individuals, often in hay fields like this one. And I would go to find those flocks and calculate the age ratio, which is just the ratio of juveniles to adults in the flock. And I was also looking at some foraging metrics, which I'm not going to talk about today, but do check out my thesis if you're interested. So what happens to age ratio during the breeding season? The proportion of juveniles increases quite strongly. So at the very beginning of the season, as you might expect, there are very few juveniles in these flocks. But by the end of August, a lot of adults have already left Iceland. And so the proportion of juveniles in the flocks continues to increase throughout the month. We can compare this with some very similar work that Thomas Gunnarsson did in 2005, where we see a quantitatively similar pattern with an increase in proportion of juveniles, but even more strongly. So he didn't see any adults at the end of August, whereas by the time I had to leave Iceland, there was still about a quarter of adults hanging around in these flocks. But what does this mean for the social environment of a juvenile? Well, if you hatch very early, you're likely to be surrounded by experienced adults who know where to go and where to forage in Iceland, and they also know how to find a good wintering site when they migrate. Whereas if you're a late hatching juvenile, you'll be in one of these flocks, mostly with a bunch of other juveniles who don't really know what they're doing, but they've been left behind without adult supervision. For the second part of this talk, I'm looking at a broader scale pattern. So does timing affect juvenile settlement in wintering sites all across the flyway? And to do this, I needed a huge amount of data. So in Iceland, people have been ringing chicks. We've got over 1,300 chicks marked, along with 800 and something adults. This ringing of chicks started in 1999, so we now have 2 decades of data. Over 70 ringers have been involved, with a special shout out to Pete Potts on the second from the right here, who's done a huge amount of work up in Iceland. We then have thousands and thousands of wintering observations as well, with over 1,000 citizen science observers. So it's a really cool colouring data set to look at these questions with. I then put these data into a multi-state mark recapture model in Nimble and R, which I'm just going to explain without mathematics and with cartoons. So chicks can hatch, after which they can recruit with some probability. And I've defined recruitment as just surviving until the first winter for the purposes of this study. And as well as recruiting, the juvenile will also settle somewhere in the range, perhaps the UK in the north or Portugal in the south. And there's a couple of ways I've tried categorizing wintering site, which I'll come on to. After their first year, they can hopefully continue to survive, and they might also change their wintering site between these categories. And then this is a process that will continue for the rest of their lives. And then we can use this model to ask some questions. So how does hatch date affect these processes on the left, like recruitment and settlement? And for example, does age affect survival or the probability of changing your wintering site? So the first thing I did was to divide the range into north and south. Jenny Gill has shown that most of these newly colonized sites are more than 52 degrees north. So that was an obvious point to draw a line and say, okay, north is above and south is below. What happens? The most strong pattern that comes out of the data is that earlier hatching chicks have a much higher probability of recruiting into the population, about 50% chance, decreasing throughout the breeding season. We also see that earlier hatching chicks are more likely to spend the winter in a southern site, and the late hatching chicks, while there's some variation around these estimates, are more likely to settle in the north. Here we have the survival and transition probabilities in the first, second, and then third winter onwards. These estimates for juveniles have a lot of variation, so I'm going to focus on the estimates for adults. And what's interesting is we see survival appears to be higher in the north of the wintering range, but also the probability of changing your wintering site, this transition probability down the bottom, also appears to be higher in these sites. We can also see that juveniles appear to have a higher probability of changing their wintering sites than adults do, who we already knew have very consistent wintering behavior. I also divided these wintering sites into traditional versus newly colonized sites, so sites that were used in the 1960s versus the sites in yellow here, which have been colonized since then. We see exactly the same pattern with recruitment down to about 1 decimal place with the estimates, which is great because these models are completely independent statistically. And an even stronger pattern comes out with settlement. So early hatching chicks are very likely to settle in a traditional site, and late hatching chicks are much more likely to settle in a newly colonized site. Similarly, we see much higher transition and survival probabilities in the newly colonized sites compared with the old. And again, perhaps a tendency for juveniles to be more likely to change their wintering sites than adults. So how does timing affect settlement? Well, here's some Godwits who hatched earlier. I took these pictures on the same day in Iceland. One in the north hatched a lot earlier than the one on the bottom. Sorry, the one on the top hatched earlier than the one on the bottom. So an early juvenile is more likely to recruit into the population, more likely to settle in the south, more likely to settle in a traditional site. This late hatching fluff ball on the bottom, less likely to recruit at all, and if it does, more likely to settle in the north of the wintering range in a newly colonized site. And this may be because when it's in one of these post-breeding flocks in Iceland, there are fewer adults around, leading to less opportunity to learn how to survive in Iceland and where to settle during the winter. So how could this lead to a range shift? Well, we think there are more late chicks in the population. If you remember this map, the population has expanded into colder areas of Iceland where breeding happens later. It also seems that the breeding season has got longer, which means there are more late adults around in Iceland for chicks to hang out with. This might be linked to more re-nesting. And also, we see there's a differential in survival, with it being higher in newly colonized and northerly sites, which is something I'd like to dig into a lot more at the moment using integrated population models. So to sum up, this is a system where timing is super important. So social environment varies throughout the breeding season, with later hatching chicks being more likely to settle in new sites and in the north of the wintering range. I suggest this may be because of a role for social information in the processes of recruitment and migration and settlement. So with that, it just leaves me to thank my co-authors on this talk, everyone that's ever ringed or observed a color-ringed Godwit, my friends who helped with the fieldwork, and my funders who helped with the money. And thank you for listening.